Hello everyone, this is Teacher Lou from Delta Learning Space. Today we are going to be diving into the number line. We will look at what the number line is, how we can interpret it, and how we can represent it at different scales. Ready? Let's get into it. But before we get started, I wanted to share a few resources linked in the description below. In this description, you'll find a link that will take you to a free number line guided notes page, as well as two different number line problem sets. The first problem set is designed to test general understanding, while the second is a bit more difficult and focuses on applying that understanding. The number line that we will be exploring today will be a way that we can represent the real number system. We will look specifically at an integer number line, fraction and decimal representations, and how absolute values can be seen on the number line. The number line is a visual representation of numbers as points along a straight line. It shows the relative order of real numbers, and each point corresponds to a specific real number. For example, we have our number line shown here. As you can see, there are tick marks with numbers shown below. So here, this mark is indicating the value of -8, -7, -6, and so on as we continue to the right. In this representation, we have our negative numbers shown on this left-hand side, our positive numbers shown on this right-hand side, and 0 in the middle. The order is important because we need to make our number line sequential, starting from the lowest value we want to show and increase to the highest value that we want to show. So remember, numbers to the left of other numbers will always be smaller than numbers on the right. And the last thing before we move on is that a number line should always have arrows on the left and to the right. And this will show that these numbers continue in both directions. And we can shift this to whatever number set that we need. The number line is a great way to visually compare numbers. In our first guided practice, we will use the number line to compare the following inequalities and determine which value is greater. For our first problem, we are comparing -2 and +2. Here I've highlighted both numbers on the number line. The greater number will always be farther right than the lower number. So in this case, +2 will be greater than -2. When we write our inequality symbols, we always want our symbol to open toward the larger value. The alligator opens its mouth and eats the larger number. Next, we are comparing 0 and -8. As we can see on the number line, we have -8 and 0. 0 will be further right, making it the larger value. Negative numbers will always be farther left than 0 or positive values. So if we're comparing a negative to 0 or a negative to a positive number, it will always be less than. And we can apply that directly to our next problem. Here we are comparing -6 and +1. The positive number will always be greater than the negative number. And so I can write my inequality opening towards 1. Our last problem on this guided practice, however, is comparing two negative numbers. So I am going to highlight those here. We have -3 and -4. And once we highlight them, we can see that -3 is farther right than -4, making it the larger value. Negative numbers closer to 0 will be larger than negative numbers farther from 0. Now let's have you try on your own. Take a second to pause the video and using the number line, compare the following values. For our first problem, we will have -3 is less than 0, +7 will be greater than -7, -5 will be greater than -6, and 2 will be greater than -8. How did we do? Remember, negative values will be less than 0 or positive values. Numbers found farther on the right of the number line will be larger than those found farther on the left. The number lines that we have seen so far have been integer number lines spanning from -8 to +8, but that is not the only representation that we have. We could have shifted that number line to show only positive values, negative numbers, or even show a much larger scale. Here, however, we are going to zoom in and show a number line with much smaller scales representing fraction and decimal values. Our first number line has values shown at -2, -1, 0, 1, and 2. But there are also tick marks in between. Values on number line should always be evenly spaced, so here we need to count the number of spaces in between 0 and 1 to help us determine the scale. Here we have 1, 2 spaces that get us from 0 to 1. So what that means is that our number line is scaled in halves, meaning we have 1/2 here and another half here to make up the one whole. So between 0 and 1, I can write 1/2, and between 1 and 2, I can write 1 and 1/2. And in the negative side, I can write those opposite values because we will have symmetry at 0. While I have my positive side to the right, I will have equal scaling on my negative side to the left. So we're at -1/2, -1, -1, and 1/2, and 2. I could have also written these as decimals. 1/2 as a decimal is 0.5. So I would go from 0 to 0.5 to 1 to 1.5 to 2. On the negative side of things, I will go from 0 to -0.5, -1 to -1.5, and then to -2. And so when we have the positive side of our number line, we can always write the opposite numbers on the negative side. Let's take a look at our next number line. I can use the same method to determine the scale. I have 1, 2, 3 spaces in between 0 and 1. And that means that my scale will be in thirds, and every tick mark should be 1/3 apart. And so I can write 1/3 here and 2/3 here. If we're doubtful why these two tick marks represent thirds, it's because I'll have 1/3, 2/3, and another way that I can write 1 is 3/3. And so now I have my 3 parts to make up that whole. If I continue, I will be at 1 and 1/3 and 1 and 2/3. And using my knowledge of opposite values, I can write the negative side in as well. So I will be at -1/3, -2/3, -1, -1 and 1/3, and -1 and 2/3, and finally -2. So when we have tick marks in between to show us that we won't be counting by ones, we can count the tick marks in between two known values. We can then evenly divide that up to help us determine what the scale is. I can also write these as decimals as well. Thirds, though, do get written as repeating decimals, so that would be 0.3 repeating, 0.6 repeating, 1.3, If we're having trouble making those fractions to decimal conversions, please check out our fractions and decimals revision video. Now onto our last number line. Same as above, we take a look at how many spaces are between 0 and 1. So I have 1, 2, 3, 4 spaces, which means that my number line will be cut into fourths. And I can fill out my number line like this: 1/4, and remember, we can always fill out our negative side using our knowledge of opposite values. 1/4 here, -1/4 here, 2/4, -2/4, and so on. And lastly, I can convert these to decimals and write the scale like this. Let's do some practice. Here, the question is asking that we fill in the missing values of the given number with the appropriate scale, and to write both the fraction and decimal equivalent. And so to do this, I count the spaces, and I have 6 spaces in between 0 and 1, meaning that my number line is cut into 6, or scaled into 6. I can write that spacings to be 1 6, 2 6, and when we have that fraction, I can just keep counting up to be 1, 2, 3, 4, 5 in the numerator, because remember that 1 can also be written as 6 6. And so now I'm just going to continue. And here I'm not worrying about simplifying at the moment. I just want to have this scale. And then I can write my opposite numbers and I will have symmetry at 0. So if this is 1 6, we will have negative 1 6. But it also shows why sometimes not every tick mark gets noted, and that's because we can run out of room or our number line can look a bit crowded. Now I need to write my decimal equivalent, and just as a small practice, I'm going to show you how we can convert 1 6 to a decimal. And so if I'm converting 1 6 to a decimal, I am going to write the 1 on the inside with the 6 on the outside of my division. We always want to put the numerator on the inside and the denominator on the outside. I'm going to put a decimal here and just add a few zeros. 6 goes into 1 0 times, so I'm going to put 0 in a decimal and then go 6 into 10. 10 can be divided by 6 once. 1 times 6 gives me 6, and then I can subtract that out to get 4. I drop down to give me 4D, and then I can repeat. 6 can go into 40 6 times. 6 times 6 is 36. And then if I add another 0, I would drop it down and get 40 again. And so that is going to repeat. And so 1 6 will be 0.16 repeated. And the negative version will be negative 0.16 repeated. So the rest of the conversions I've already done, so I'm just going to write those in. And then I do want to point out that here we won't have any repetition in our decimal, and that's because 3 6 is equal to a half. Now take a moment and pause the video. Write in the missing values of the given number line with the appropriate scale in both their fraction and decimal form. If we count the number of spaces in between 0 and 1, we will see that we have 10 spaces, meaning that our scale is divided into tenths. I can write my fractions like this. And their negative counterparts. And lastly, I can convert my tenths into decimals, and they come out nicely like this. How did we do? Now that we've practiced learning how to write number lines at a smaller scale, we are going to use that to compare fraction values. Here we have a number line, and below we have values that we want to compare to determine which one is greater than the other. Take some time and pause the video and try it on your own. First thing that we want to do is understand our scale. Our scale is in 6, and we can use that to help us compare our values. Our first problem is comparing -1 and 5 6, so I'm going to highlight each of those values on our number line. As we can see, 5 6 is further to the right than -1, and so that means 5 6 will be greater than -1. Remember, positive values will be larger than negative values, even though the fraction may not seem like it. Our next problem is comparing two negative values. So again, I'm going to take some time and highlight those on the number line. My negative 1 and 4/6 will be here, with negative 1 and 1/6 being there. Because negative 1 and 1/6 is further to the right, it's also closer to 0, it will be greater than negative 1 and 4/6. So our last problem, we're comparing two positive values. Here we're comparing positive 1 and 4/6 with positive 1 and 1/6. On the number line, 1 and 4/6 will be further right than 1 and 1/6, making it the larger value. The last topic that we have for this video is about using the number line to understand absolute values. Absolute values reference the non-negative distance of a real number from 0 on the number line. This focuses on the magnitude of a real number, not the direction. And we can write absolute values within these bars like this. And so this question is asking, what is the absolute value of 3? I can also write an additional question of what is the absolute value of negative 3. And so if I want to find the absolute value of 3, I'm going to take a look at my 3 on the number line and see how many spaces it takes to go from 0 to 3. It takes 3 spaces, and so the absolute value of 3 will equal 3. So now I can take a look at the absolute value of negative 3. And so if I want to look at negative 3, I want to count the spaces from 0 to negative 3, 1, 2, 3. And so it also takes 3 spaces. So the absolute value of 3 is 3, while the absolute value of negative 3 is also 3. And that's because in both directions, it will be 3 units away from 0. We care about the units. We don't care about the direction. Now pause the video and take a moment to determine the absolute values of the problems below. Because absolute values worry about the distance from 0 and not the direction, our answers will be as follow. The absolute value of negative 1 will be 1. The absolute value of 17 will be 17. Of negative 9 will be 9. The absolute value of negative 1/6 will be 1/6. We'll have 9 there. And 0, because we are 0 units away from 0. How did we do? Thank you so much for sticking around until the end. It was a pleasure learning with you, and keep up the great work. See you next time.